Welcome to another video. In this video I have got a FNIRSI, I think, LCR-P1 transistor tester. I'm not too sure what it tests, just transistors. Does it do diodes, capacitors and inductors? Yeah, I don't know. I'm not going to try and figure it out. Arrive with a slight bit of damage to the box. But let's have a look. All right, and here we are. Okay, looks nice. Got this type of thing here for where you put your transistor legs into it. I don't know yet. I haven't read the book on it. Take it out. Okay. Not too sure yet what it is. Okay. What have we got in this little box? A couple of leads. Instruction book. USB-C cable. A-type connection. These must be the leads, 3 leads for the transistor tester, cum diode tester, I would imagine. And we got this device here. I would imagine this is for, how are we going to work this? How is it used? But anyway, look, I'm going to look at the instruction book and figure a little bit more out, and I'll get back to you on it. Just a card, just saying it passed. It's quality control. Okay, this might need to be charged up. I don't know. Oh, okay, just press the test button. Unknown. All right. All right, what I'm going to do is read up and have a look at it then. I read the book. It does do resistors, diodes, transistors, FETs, Zener diodes, I think. Diacs and triacs it mentions as well. Now, I don't have any diacs and triacs in stock as far as I know. It's not something I use commonly. But I do have a selection of resistors out here first, just to check them first and see what happens. Just connected them here, just randomly took any 2 of the 3 cables that I have plugged in here. And I'm going to just press the test button to switch it on. It says unknown, no component or damaged. I'm going to test. I don't know what value this is. It's poorly marked. So it's telling me 1 ohm. Okay, all right, we'll accept that that's 1 ohm. I had in a bag and it said 0.68. I think the next one should be 47. Test. Yeah, 47.5 ohm. That's correct. Let's see a 470. 470.9, which is dear enough. And the last one, it's in the meg. I think it's 10 meg. Yeah, 10 meg. That's the packet I got it out of anyway. Yeah, that's the test button. Oh, 15.1 meg. Okay. That's high, isn't it? I'll have to double check that now. With the multimeter. And see what I have. On the multimeter is telling me 12 meg. So just a little bit out, but I wouldn't be using them for them high values anyway. You wouldn't use it for the lower values really, because the multimeters are very poor at the lower values. Okay, I'm going to get a selection of capacitors out now. I had a look at the footage of the last segment, and it clearly showed that it was reading a capacitor, not a resistor. And what I've done this time is I've connected the resistor directly into the tester to see how it performs with that, because it might be that the leads themselves weren't getting a good contact on the resistor at the time. They are made a little bit flimsy. They could invest a little bit more money in them. Very cheap looking, whilst the rest of the tester looks of good quality. Anyway, let's do the test. Okay, it shows 12.59 mega ohms, which is close to what the reading I was getting on the multimeter. Okay, we'll go on now to the next test. Okay, I have a selection of capacitors here. See what we get. Electrolytic one, and this is 470 microfarads. I would imagine it's going to take a little bit longer. The test capacitors. 478 microfarad. ESR of 0.21. Okay, all right, that's that one. Now to know about the ESR, I'm going to have to get the chart out. Okay, what's this? 2.2 microfarad. Mm, 2.27. Sorry, 2.1 microfarad. Okay, 2.27 ESR. Okay. I got one here, 3 kilovolts, and all it says is 5D on it. Okay, so measure the capacitance of the leads, most likely. Take my fingers away from these low values. Okay, read an open circuit. Get a good connection. Test again. .48 microfarad. It can't be 48 microfarad. Test it again. Eight picofarad, and it's got 5D on it. Right. I had one little glitch there. I don't know why I read that high value. Maybe it's because I got long leads. There's some interference it's picking up on them. I don't know. Test this one. This is probably a 12 pico. 14 picofarad. So it is reading roughly around where it should be for the capacitance. Doesn't take too long to read it. Obviously for the ESR, this doesn't come with a chart, so you'd have to get your chart out there beside you and make sure for the voltage and the capacitance rating that is correct. So on to transistors now. I have a selection of silicon here, mixture diodes, I think an FET, transistors. Let's get a start on them, see what they say. This here is a BC639. Okay, it's telling me it's an N-type transistor, HFE of 92. Current of 858 microamps. Okay, and a base emitter voltage of 0.614 volts. And 614 millivolts. Okay. Sounds about right. I'll have to look at the data sheet. You have a diode now. It's a normal common bog standard 1N4007. Okay, recognizes a diode. And it's got a voltage drop of 656 millivolt, which is about right. A capacitance of 11 picofarad. Okay. Another diode, which is okay, BYW 98200. Okay. Reading as a resistor. Am I getting it correct? Connection. That's not reading right, is it? Okay. I turned it around and recognise it as a diode. Maybe you have... Oh, that's correct. You have to turn it the right way around for diodes. Otherwise, it just doesn't read it. Okay. 0.485 millivolts. Now, we got this oddball one here. AA130. That's all I have on it. Okay, it reads as a resistor, so I'm going to turn it around. Yeah, they don't get a really good grip of these smaller leads. So I'm going to put a bit of tension on them. Doesn't know what to do with this one. Turn it around. Okay, maybe try these other two leads. Okay, looking at that there, either one of them is 8, so it has to be this one here, anode. This one here should be cathode. Try again. It says it doesn't know what to do with that type of diode. I don't have much data on it, but all it says is germanium. I'll have to look up for a data sheet first. Okay, we got this. It looks like an FET. See, it looks like an FET. Okay, yes, it comes back as an FET. Field effect, tube, any MOSFET. Red lead is the gate, and the blue one is source, or the green one. Sorry, number 2 is source. It's got diode. Yep, that's okay. I wish the screen was just a little bit bigger on the tester. It would be easier for me to read, you know. I could see it, but just about. I'm going to test this diode that I can't read on the multimeter, see what it says. If it doesn't read it on that, happy days. I'd be able to rely more on this than if it fails on this. Let's have a look. Voltage drop across this diode is 0.28, which is about 0.3 of a volt. It doesn't seem to be able to handle that. I'm going to retest this diode now, and I'm going to plug it directly into the tester to see how it performs like that. As with these cables, they sometimes don't get a good contact on the leads of the component. So let's see. Switch it on. Let's do the test. Okay. It's 0.625 millivolts voltage drop across it, which is higher than what I'm seeing on the meter, but it's reading it anyway. I would have to put it down to not get a good contact on the leads. That's why it was showing up as a resistor. On to Zener diode testing. Okay, I have a 5.1 volt Zener diode here. It doesn't look like the best of quality, but I would originally got them from a company here in Ireland that they distributed parts for TV repairs, or probably about 20 years ago. They're that old. So you have to fit them in to the 3 pins here, this side where it says cathode, anode, and anode, either one of those, and put them in. Okay, lock it in. Switch on the unit. Press the Zener. Now press test. Okay, 4.17 volts, which is a bit lower, about 1 volt lower than what it's specified on it. I wouldn't be surprised with that, with some of these components from that would have got years ago. We still got fake components back 20 years ago, like we do now. But I've already tested this on the power supply as well. I normally use a power supply for testing Zener diodes, and it shows up about 4.2, 4.3 volts, which is very close to what it's saying on this. So I'd say it's accurate enough for that. And on to the next. Right. Next thing I'm going to look at is this little board that was sent in with the unit as well. It comes as part of the package, and you notice there's a notch at one end. I would imagine, I haven't used it yet. It lines up with the notch that you see on the unit itself. There's a little notch on in the plastic, so you can't put it on correctly, and then you just plug it in. And now you can use it for surface mounted devices. I won't test it with this board. I'm sure it works. When I'm here, I might as well pull this plastic off. Yeah, good luck with that. Didn't come very well. No, that's better. In summary, what do I think? Well, this here will not do every surface mounted device, so there want to be some available on the market, or if you're capable of making them yourself, I'm sure you would be able to get a PCB way to be able to do that for you, make you up one of them. And they could upgrade these for next a few euro on the price of it. Better cables. These are very flimsy and fiddly. Would I use it every day? No, I would still stick to my multimeter and my oscilloscope for most of my problems. I would use it for trying to identify a component that I had no data on, whether it was an FET or a transistor, Zener diode. Yes, it's handy for that. But for normal everyday use, no, I'd keep it there as another test tool, as we all have specialized test tools for testing. Okay, thanks for watching.